Okay, our topic is inverse of trigonometric functions. From the previous term, if you remember that we said not all functions has its inverse. Only one-to-one and at the same time onto functions has its inverse. Now, what about the trigonometric functions? Are they have their inverse? Let's look at the graph of our sine function. Again, now as you see in here, we have the graph of sine function. Yeah. Now you know that graph of the sine function is periodic. The sine function is periodic, so it's not a one-to-one function. Yeah. For different values of x, we have the y. For example, for when sine pi over 2 is equal to 1, and sine 5 pi over 2 is equal to also 1. So this function doesn't have inverse. But if we limit the domain of this function, between minus pi over 2 and pi over 2, now we will have a function which is a one-to-one. Yeah. The sine function whose domain is between minus pi over 2 and pi over 2 has its inverse. Yeah. And also, if you remember, we said that the graph of the inverse of the function is symmetric with respect to this straight line. Yeah. This blue line is our function whose domain is between minus pi over 2 and pi over 2, and the red line is the inverse of our sine function, which is called arcsine. Okay, now let's look at here. Now, inverse of sine x, we said it's arcsine. Inverse of cosine is arccosine. Tangent, arctangent, and inverse of cotangent is arccotangent. On this video, we are going to learn about the arcsine and arccosine. Okay, now look at it here. We said function is the rule that assigns each element from here to here, yeah, to the range, from domain to range. And we limited the range domain of the sine between minus pi over 2 and pi over 2, so it will be one-to-one function. And the inverse of the function, its inverse it just undoes what function does. Yeah. So if function assigns elements from here to here, so the inverse of sine function, it's in here, undoes. Now it assigns the elements from here to here. Yeah. Now the value of inverse of sine, it's arcsine. The value of arcsine must be between minus 90 and plus 90. Look at it here. This is our function. We can substitute x in here, the numbers between minus 90, minus pi over 2 to pi over 2, and the result will be between minus 1 and 1. And the inverse of this function is arcsine, this one. We can substitute y, the numbers between minus 1 and 1, and the result will be, the value of the arcsine will be the number between minus pi over 2 and pi over 2, between minus 90 and 90. Yeah? Arcsine, the value of arcsine is the angle, and so it must be between minus 90 and plus 90. Here we have the graph as you see here. Now let's solve some examples. We have to find the arcsine 1 over 2. What does it mean? Okay, this means this is the angle. The question is, for which angle between minus 90, we said that the value of this one must be between minus 90 and plus 90. Here's the question, for which angle between minus 90 and plus 90, this value of the sine will be 1 over 2, yeah? We have in here sine x must be 1 over 2, and what must be the x, which is between minus 90 and plus 90, so sine x will be 1 over 2. That is what? That is 30 degrees, yeah? Which is pi over 6. Okay, let's solve another example. Here, this one, the question is, for which value of, for which angle between minus 90 and plus 90, the sine will be minus root 3 over minus 90 and plus 90. We have to find the angle between minus 90 and plus 90. So the sine for that angle will be minus root 3 over 2, yeah? And the sine is negative on the fourth quadrant. That must be, angle must be less than 90, less than 0, and negative. So the sine x is equal to minus root 3 over 2, and arcsine minus root 3 over 2 is what? The angle which is less than 0, for which sine will be minus root 3 over 2. It's what? Pi over 3. Minus pi over 3, yeah? Okay. Now let's solve another example. Now let's give another example. Wow, look at it here. And this one. Arcsine is equal to root 2 over 2. Arcsine root 2 over 2. And we have to find, this is pi over 4. This is sine pi over 4. Sine pi over 4 is equal to what? Root 2 over 2. So, sine arcsine is equal to root 2 over 2. Okay, the next topic is inverse of the cosine function. That is arccosine. Now, the domain of in here, we will limit the domain of the cosine between 0 and pi. Here, between 0 and pi. And so, the function, the inverse, the range of the inverse function will be between 0 and pi. This is our function. This is the inverse of the cosine, arccosine. The value of arccosine, its x, is between 0 and pi. Let's solve examples. Okay, here we have this one. The question is, what must be the angle between 0 and pi? 0 and pi. So the cosine for that angle will be 1 over 2. Cosine x is equal to 1 over 2. We have to find the x between 0 and pi, for which cosine is equal to 1 over 2. It's what? 60 degrees. X is equal to pi over 3. Yeah? Okay, let's solve another one. Let's solve this example. Okay, now cosine x. We have to find cosine now root 3 over. Now the angle x in here must be what? Cosine 30 is equal to pi over 6. Cosine pi over 6 is equal to root 3 over 2, and pi over 6 is between 0 and pi. And here it's pi over 4. This one is pi over 4. And the result is equal to 12 to pi and 5 pi over 12. And that's all. I think it's understandable and clear. On the next lesson, on the next video, we're going to learn about arctangent and arccotangent.